Welcome to our lesson on the magnitude of the cross product. So in the last lesson we learned what the cross product was, the cross product of two vectors in R3. So that's A, that's B, then the cross product is the vector, or is a vector, which is perpendicular to both A and B. So this would be A cross B, and we made the point that there's actually lots of vectors which are perpendicular to both A and B, right? They would have different magnitudes, and they could also be in the opposite direction. And we said that A cross B will follow the right-hand rule. Meaning that if A was your index finger, B was your middle finger, then the cross product will be in the direction of your thumb, for your right hand. And we determined that you could figure out such a vector by using this formula right here. So this is what we call the cross product. But the question now is, how long is A going to be? How is the magnitude of this vector going to be related to A and B? And it turns out that the magnitude of A cross B let me draw A and B again. So A is there, B is there. Well, we know you could then sort of form the parallelogram. So that's B and that's A, just repositioned. So this forms a parallelogram. You know, we saw this where you added A and B, right? It was the diagonal of this parallelogram. Well, it turns out the magnitude of A cross B is actually equal to the area of this parallelogram. To the area of and you know that's totally not obvious that this formula up here, the magnitude of this vector, is going to be equal to the area of this parallelogram, but it turns out it's true. Formed by so let's just let's see how we can come up with that, like if there's an equation for that. So A cross B is equal to the area of parallelogram. Well, what is the area of the parallelogram? Can I come up with an equation for that? You know what, this is a bad drawing. I'm going to draw B horizontal. Just makes it a little bit easier. Then A will be like that. So then the parallelogram looks like that. It's easier to think about the area. So if you remember, the area of a parallelogram is equal to the length of the base, which in this case would be B, or the magnitude of B, times the height. So that would be equal to the magnitude of B times this line right here, which is H. Well, H is related to A. If theta was the angle between A and B, then H would just be equal to this basic right angle triangle right here. So sine of theta equals H over magnitude A. So H would equal sine theta magnitude A. So that's just basic trig ratio. So it's equal to the magnitude of A times the magnitude of B times the sine of theta just by substituting this into that. So A cross B is equal to this. So this is a formula for the magnitude of A cross B. And just going back to that original formula for a cross product, right? This thing right here. It turns out, like, you can show that. You can show that if I calculated the magnitude of this by using your magnitude formula, you could get this. And I'll put that in another video because it's not that difficult to do. It's just a lot of you can imagine calculating the magnitude of this. It's just ugly, right? There's a lot of terms, and you just have to kind of reduce and factor it in the right way. So I'll put in another video. It's not really that essential that you know it, but it's sort of interesting to see because when you look at this, it doesn't look anything. You sort of think, how could I get that from this? But it turns out you can. Okay, so now we'll just do some examples to see how this will be useful. Well, okay, so very simple example, very straightforward. You're given two vectors A and B. We want to calculate the area of the parallelogram formed by A and B. So if this is A, this is B, that would be the parallelogram just by moving A and B over. So we want to get the area of that. So we showed that the area of the parallelogram, or we said that the area of the parallelogram is equal to the magnitude of A cross B. So that's what we want to find. So first thing we're going to need to do is find A cross B. So we'll just use that formula that we had before, or the formula for cross product. So let's, if you remember the formula, it's equal to A2, so 2 times B3, 0, minus A3 times B2, so that's your x component, and your y component would be A3 times B1 minus A1 B3. That's your y component. And then your z component is A1 B2 minus A2 B1. Figure out what that vector is. So that's negative 3, negative 6, negative 6, and 1 plus 4, 5. So this is A cross B. So now, to get the area of the parallelogram, we just take the magnitude of this vector. So the magnitude of a vector is equal to the square root of its components squared and added together. So that's just your magnitude formula. So 9 plus 36 plus 25 equals the square root of, that's 70. And then 70, square root 70 doesn't reduce any further, right? There's no perfect squares which divide that, so you can't, unless you want it to go to a decimal. But that will be the area of the parallelogram. Okay, so we'll do one more example. Okay, so here's our question. We want to find the area of the triangle with vertices A, B, and C. So, well, this is not quite as obvious how we're going to do this, but let's think about a triangle with vertices A, B, and C. I'm not worrying about where they are. I'm not actually plotting this in R3. So that's the triangle we want to find the area of. Well, if you think about this as a vector, and think about this as a vector, then we could look at, the parallelogram formed I'll call that vector A, and this vector B. And I could look at that parallelogram, then I know I can get the area by doing the cross product, but I'm actually looking for the area of this triangle, but the area of the triangle is just half the area of the parallelogram. So let's just do the area of the parallelogram, which is easy using cross products, and then just divide in 2. Okay, so the first thing we're going to need to do is figure out this vector A. Okay, so vector A. And actually, let's not call it vector A. Let's call it vector AB. Okay, so this vector here, AB, is equal to the B components minus the A components. So it'd be minus 2 minus 1, 0 minus 2, 1 minus 3. So vector AB is negative 3, negative 2, negative 2. And then we need this vector here, so vector AC. Over a bit. AC would be the C components minus the A components. So 0 minus 1, 4 minus 2, 2 minus 3. So negative 1, 2, negative 1. We then want to get the area of the parallelogram, so we'll do the cross product of AB cross AC. So that would be negative 2 times negative 1 minus negative 2 times 2. Probably have to move over a bit. So that's your x component, your y component, minus 2 times minus 1, minus 3 times minus 1, and your z component, minus 3 times 2, minus 2 times minus 1. Be 2 plus 4, 2 minus 3, minus 6, minus 2. So this is the cross product of these two vectors. So now we'll do the magnitude to get the area of the parallelogram. So 6 squared plus minus 1 squared plus minus 8 squared, 36 plus 1 plus 64 equals the square root of 101. So that's the area of the parallelogram, so the area of the triangle will just be half of this. Therefore, is square root 101 divided by 2, which if you want you could get it as a decimal. Okay, so that's how you get the area of a triangle from the area of a parallelogram, which you can get from the cross product.